Good morning everyone. Welcome to lecture 4. So, as a follow-up to lecture 3, I have posted a video talking more about integer division, floating point division, and rounding errors inside floating point arithmetic, and why that is very critical, and how you can control a little bit of aspects using rounding modes. So please watch that video as well. So what I suggest is that to all the students that you can subscribe and set the notification, so that if there are these supplement videos that I may put, you will immediately get notified. So in your lab session last week, right, so there were certain exercises that were asked that you have to write some programs that accepts input. Okay, so now let's talk about that if you haven't already learned that. So let me just quickly write a program. In fact, let me also increase the font size so that you are able to see that. So you know that how to declare variables, and now what we want to do is that we already know how to print things, but what we want to do is that we want to accept input from user, in particular from standard input. So there are three standard streams. One is standard input. So typically it is connected to your console, but your standard input can be connected to a pipe or a file, etc. Okay. So for that, the subroutine, so I'll call it subroutine. The C programming language, this is called a function, but it is again not a mathematical function. And you already know that for integer the format specifier is %d, right? So it is the same format specifier that I am going to use over here. And now in fact we want to read two numbers. So we will write that I want to read two numbers. So just like for printing, if you want to print few values, then you will write that many specifiers. And similarly, I want to read two values. So what I will do is that I'll say that I want to read two integers, %d, %d. And now this is something new. Okay, so I have written this thing called &a and &b. It is called an addressof operator. So I mean, what's the point of that? So we'll anyway talk about it in detail at some time later, but we have mentioned, right, that every variable, so for example we know that int is 32-bit, and these are, in mathematics we are calling them state variables, and then all the statements in the program, they are state transformations. We have talked about that in lecture 1 and 2. But the thing is that is all mathematics, state transformation and state. But in your computer, it requires some space that where exactly this information is. So for example, when you do a is equal to 5, it has to change the bits of a, which is 32 bits of a, to look like some let's say 0x 00, this is 1 byte, second byte, third byte, and 5, or in fact, and this is a 4-bit pattern which is going to look like this. So it has to store somewhere, right? So where it is going to do that? So that part, the location where it is supposed to change the bit pattern, that location is called address. So given a variable a, &a gives, it is a unary operator. So when you use it in a unary sense, so &a, followed by a variable, it is going to give you the address of that variable. the location. And now what do I mean by address? So in your computer, you know that your computer comes with let's say 4 GB RAM. So when you say this 4 GB RAM, now each essentially that there are that many bytes, and there is something that is called a word in memory, because not every byte may be addressable in your computer or in your architecture. So typically, not typically, but many times the word size is 4 bytes. That means that in the chunk of 4 bytes, you can give address. So essentially, this address could be, so 0x, I'm writing for hexadecimal. So after 0x, I'll write a hexadecimal number. So let's say 0x10, 0x11, and another 4 byte is for 0x12. So these things that you see over here, right? So these are called address of the location. And just like, for example, you know that on the internet you are typing www.google.com or youtube.com, etc. So these are nice names given so that we can easily remember, but behind the scene there also in the website there is something called an IP address, which is a set of numbers. But since we are very bad at remembering numbers, so this is much more human readable, so that's why we give this nice names to variables. And I'll show you that behind the scene these are all numbers, all these addresses. And now, so let's say this is one address, this is the next address, this is the next address, etc. So when you declare a variable, when you say int a, some address is allotted in your RAM, that let this be the address for variable a, and that address, that number, is indicated by %a. Yeah, so now when I come back over here, I am saying that you read this value using %d, so it is a format specifier. Now there are a lot of format specifier, we talked about it in lecture 3, and in addition I think that if you just Google it, so I'll put this link, there are several other links are available. So there are a lot of format specifiers for printing, and there are some subset of that is available for scanning. So I'll say that %d is essentially that I want to read an int value, and where do I store that value, and that is why I am giving an address. So I say that you take this value and store it in this address, and similarly you take another value, you store it in this address. So now I know that there are so in variable a there will be some values. So at this point, after declaration, do I know that what are the values inside a and b? No, I don't know, as we have said that it is an uninitialized variable, we have not given any value. After this point, do I know what is the value? After this point also I don't know any value, because this so your program, any program which does not interact with its environment, right, outside. So when I say environment, it could be anything that is outside the program, then that program is useless. So we know that we write programs to accomplish certain tasks in real world, and for that to happen it has to interact outside. So we are trying to interact with the user, that okay, you give me an input. So these two inputs are taken, A and B. I have no idea. So in the state space, right, we have drawn this. So we know now we are somewhere where we still don't know that what is A and what is B. We are in this state. As a programmer, it is kind of a bad situation to be in. What is the state of your program? Because you want to do certain things depending upon what your state is. So for that, almost all of the programming languages gives you a way to test that what is your state, what state you are in, right? So for example, now let me just digress a little bit and talk about predicates. Now why I am talking about predicates, and if you do not remember, predicates are nothing but mathematical functions. So all predicates are mathematical functions, but the codomain, so you know that you write your function from domain to codomain. So this part. So a predicate is a function for which the domain can be anything, but for which the codomain is always 0, 1 or true, false, etc. So that is a predicate. And so for example, if I say in mathematics, I say that x mod 2 is equal to 0, right? So this is a predicate over x. And what does it indicate? Indicates, so this predicate will be true if x is even. This predicate will evaluate to false if it is odd. And now, for example, you used to represent, so for sets, so let's talk about sets. So if I want to describe some set, let's say 1, 2, 3, 4, etc. And for finite numbers, finitely many elements, listing them out explicitly, it is fine. But what if you want to write even numbers, that set of all even numbers? Then sometimes people write it like this and assume that this dot 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 essentially means the person is going to understand. But a better way, and you would have learned this in your school, is that the another way to write is that it is x such that x mod 2 is equal to 0, and since if this is starting with 2, so I will write x is greater than 0, and let's say x is an integer. Right, so you see that this is set of all even numbers. So this part, as you see that x such that, and then what you write over here, this is a predicate, this part. So predicates help us, right? So in the previous slide I have seen that you don't know what x is, but you know that if the predicate evaluates to true, you have some idea that x is even. So predicates allow you to test that whether a particular element, whether it is in the set that I am interested in. In fact, predicates can define sets. I would go so far as to say that predicates and sets are in some sense two different ways to look at the same mathematical object. Right, so I can, for every set, you write some predicate. That predicate may not be computable, but let's say that you write some predicate and say that, well, if predicate is true, the element is in my set. If predicate is false, it is not in my set. Okay. So similarly, now in programming language also, so now you are in a position where you don't know what your state is. You are somewhere here, right? A is equal to star, B is equal to star. And I want to take some action. For example, let's say that you want to compute, you want to print that which number is the largest number out of A and B. So now what do? Again, you can write a predicate. So your programming language allows you. So for that, there is a keyword called if, and then you put parenthesis, and inside this parenthesis you write the predicate. So you see that your predicate is essentially you are defining a set. So what can I write? I can write that A and then this sign, which is a greater than sign, B. So now and then you put these two braces. So now I am saying that if the values of A and B, these pairs, if they satisfy this predicate, Then so if a is greater, let's say that I want to print the largest number, then I'll say that print so you say that, so now you have regained a little bit of control, that I don't know what state is, but I can use this predicate as a filter over states. That I have defined this subset. What is that subset? Instead of a is equal to star, b is equal to star, where essentially when I say star, it means any non-deterministic value inside int. Now you have regained some control. Now you are saying is that what are your states going to be? You still don't know the exact values, but what you know is that these values are let's say a is equal to, can be a is equal to 5, b is equal to 3, can be a is equal to 7, b is equal to -2, etc. But it is certainly, what you know about it is that it is not the case that a is equal to 3 and b is equal to 4. So this you certainly know that your system is not in this state. So you have discarded this state. Similarly, even this a is equal to 3 and b is equal to 3, that is also. So you write this predicate to test that my system is in some state. I don't know as a programmer in which state it is, and it is very bad as a programmer not to know where you are, because depending upon where you are, you want to do you want to accomplish certain tasks. So these predicates are a way to filter out these things, possibilities that you certainly know at this point of time. So after you come over here, I hope that you can see. So after this predicate is evaluated, when you come here, in fact let me just so after you come to this line number, so at line number 11 I have intentionally kept it blank for allowing a specific location. So after this predicate is evaluated, now you know as a programmer that I still don't know what is the exact value of a and b, but what I know is that a is definitely greater than b, and that is sufficient for me to declare that a is the largest out of these two. And so now let's say that so this is how some people have asked that how do you use GCC. So I'll use GCC and then minus small o. So this is called a flag or an option of the compiler, and then I'll write the name, that what is going to be the name of the executable file, and then name of my input file, the file in which I have written the program, right? So you can see that the name of the file is example.c over here. So I compile and it compiled fine, and now if I run it, so now it is waiting. You see that right now it is waiting for me to give two numbers. So let's say that let me give two numbers, 23 and 34, or just 3, I mean for a moment. So now it says that okay, largest number is 23, that's good. Now my program is working fine. Now is it really, right? So let's check. So now what if I go give here 23 and 34? It did not print anything. Why did that happen? Because we did not consider the possibility that this is just one part, but there is another part where b can be larger, or at least as large as a, right? So what happens is that if essentially you are saying that here your program is in some particular state, you don't know, but if the state satisfies this predicate, if it is in this set, then you perform these transformations that are specified inside these braces, I can say that else. So if my state does not satisfy this predicate, then you please do actions or please do transformations that are specified in the else block. So this is called the then block. So if then else, typically it is called. So that means if the predicate is true, then you do these transformations. So here you can write, even assignments, declare variables, etc. And similarly here. Okay. So now I know that if this predicate does not hold in this state, I don't know what the value of A and B, then what do I know? I know that B is definitely greater or equals A. So in which case I'll do and now let's see. So now I can compile my program and then I can run this program. So now let's do this thing. The largest number is 34. Let's say that what I want to do is that in fact let's run this thing once again. 23 and 23, so both the numbers, and now it is saying largest number is 23, now which is correct. But what if I want to say is that I want to print that whether the first number is larger or the second number is larger, or whether both the numbers are equal. Okay, so here now I want to change that the first number is larger and its value is so and so. Similarly, let's say that I want to write the second number is larger and actually its value, sorry, yeah, my mistake, value is, but we know that if I am here, I am at line number 16, if I am here, then I know that there are two possibilities. Again, A can be exactly equal to B or B is larger. So at this point of time I am still not sure that whether the second number is larger or not. So again I have to decide, right? So that means that I again write a predicate to decide that the state in which I am in, whether in that state whether B is strictly greater than A or B is equal to A, right? So the another thing that I can do is I'll write that B is greater than A, and then I'll put a brace over here. So now what happens? So now you see, let's recap. So you don't know what are the exact values, but at this point at line 11, now you definitely know, because you have written a predicate which acts as a filter. You have eliminated all the possibilities that certainly I know that my program is not in a state where B is greater or equals B, right? Because this predicate is true for whatever the state I am in. Similarly, now when you come over here, when you come to this line number 16, what do you know? At this point of time, you know that certainly A is not strictly greater than B, because if that was the case, it would have gone here. So the control of the program, the execution, will come over here inside this else block only if this predicate evaluates to false. So at this point of time, I know that my program is in a state where this predicate does not hold true. So then I am here. Now again I don't know that whether B is strictly larger or they are, both of them are equal. So here I can print both the numbers are equal and their values are. Now what should I print, A or B? It does not matter, right? Because both the values are equal. So I'll just, let's say, print A. So again I have to put two numbers. So now let me do this. What happened? So anyway, so let's try to figure it out. I mean, I wasn't planning on it, but let's say that if situations like this arise, you have to use something that is called a debugger. I don't know that why it is doing like this. So if you want to enable debugging of your program to help you that what is going wrong, so I'll give this thing and you give the option -G, so it will enable debugging for the program. And now you use this command called gdb. So this is available in Linux. I'm sure it is available on Windows as well. And then you give the executable. So executable file is example. So you see that the prompt has changed. And now what I do is that I want to, when it starts running, I want to know one by one at every step, I want to observe what is happening in the program. So what I'll do is that I'll introduce a breakpoint, that the program execution, it should break so that I can inspect that at this point of time. So I'll say that you break at main. That means that when the main function is called, you break. And now I say run. So here now you see that now it is showing that you are at this breakpoint, you are at this point, and example.c at main. Now I'll say that okay, what is the next instruction? So you say that okay, next is this, and now I say next. Now it is waiting. That the next instruction was scanf. Now it is waiting. So I'll write 23. So now it is here, it is trying to test. Now for example, at this point of time I want to observe that what was the state inside a debugger, right? So I can observe that by saying print A. So it is going to print this value, or I can say print B. It is going to print this value. So we know that it's both 23 and 23 are there. In fact, the debugger also allows you to evaluate an expression. So that means that I can evaluate this, and it says that is A greater than B, and it says 0. That means that this condition is not true. So now the control should go to the else block, because this predicate I know is not true. So I'll again do next. So now it has gone to this other branch. And now again, let's say I evaluate that whether B is greater than A. It says that this is also not true. So now the control should go to the else branch, which apparently it wasn't happening. So let's see. So if I do next, let's see what happens. Okay, so both numbers are equal and their values are this. I say next. And so you see that it has come directly to return 0. Okay, so this is very interesting. What is happening is that the control is indeed going there. Now when you do this printf, what happens is that it stands for print formatted. This is your format string. You are saying that you print these exact characters, and here instead of %d, essentially this are format specifier, you print the value of this expression A. But when you do that, when you execute it, it does not immediately get printed. So what happens is that this part, your program does not have control over the system, over your screen, etc. So this is a request to the operating system. So it invokes a system call. It's a request to the operating system that, hey, you know what, can you please print that? This thing goes into something that is called a buffer, a screen buffer or something. So essentially that that this string, these set of characters, so it will prepare this entire string, both the numbers are equal and their value are 23. So this thing is passed. You request that please print that values are 23. It does not immediately go to the screen. Your program makes a request to the system, because the operating system does not allow arbitrarily control over various hardwares to your program typically. So there are this interface that is called a system calls. So you make a system call, and then the operating system takes over, and then it does certain request on behalf of your program. So this is a request you made. So it was there in the buffer. It does not get to it immediately. So that buffer has to be flushed, or all the values of that buffer, that has to be read by the system and then to be printed on the. But since there is no new line character over here, what happened is that the buffers are not being flushed. So it did not print. I guess that is what is happening. It's going to return 0 without printing anything, right? So yeah, your program has ended and it did not print anything. So let's see that whether my theory is correct. I'll quit, and then, so I wasn't planning on this thing, but it's a good thing that now when you write a program, if something is going wrong, what you can do is that you can do this debug process. So that is also a very important thing to know, very important skill, debugging. So at least you got started. So you can use GDB. I have used GDB on the command line, but if you are using an IDE, it provides much easier way to use this debugger. So let me do this. So if I do a new line, whether it is going to flush or not, right? So that is my theory, that now it should work. So now this 23, and see, now it is printing. So it wasn't that, so I wasn't testing correctly, etc. All my conditions were correct. The control was going where it was supposed to be, but because the buffer was not getting flushed, and that is why, see, so these are some things. It's very important that how your program interacts with the system, that also you should know. So even though the logic was completely correct, you have to understand behind the scene that what happens. So printf is essentially not that it will immediately going to print these things, that it will first go to the buffer, and then, so if the buffer is not flushed, so what happens is that it takes all of this thing, and after some time all the entire buffer is flushed, and then it got printed. So if you do a new line here, yeah, it kind of flushes the buffer to the screen, and that's why it's getting printed. Okay, so now let's quickly again go back now. So this thing that I have done, so there is an if then else block, and inside that there is another if then else. So this is called nesting, and now inside it I can again write another condition. So for example, I can again write if, let's say, B. So I know that B is certainly greater than A, but now I want to write that whether B is greater than A plus 1. I can again write another condition, that whether the difference between these two is at least 2, right? So B strictly greater than A plus 1 means that there is a difference of value between B and A has to be at least 2, and all of this I can write. So you can do this nesting, and you can also omit this else block. So I have shown you comment in the last one, and what I can do is that I can omit this entire block. So else is not compulsory, so you can just write the if block but not the else block, in which case what's going to happen is that it will test for this predicate. If this predicate is true, it is going to do all these transformations. If it is false, then the control will directly jump to this, this end of curly brace over here, and then your execution will resume. So since there is no else block, if there is a if and else block, that means that if the predicate is true, execute this. If the predicate is false, execute this. Okay, but let's say that you want to do that whether the difference is 2 or difference is 3, difference is 4. It kind of become cumbersome, right? So let me just do it over here. So now I say that if b is greater than a plus 1, right, difference is at least 2. I'll just write a is equal to %d and b is equal to %d and /n for flushing the buffer. But now I want to say that whether it is at least 2, whether it is at least 3, that kind of quickly becomes boring. So then you can write else if. So that means that if this predicate is true, execute this. If this predicate is false, then the program control execution will come over here, and then it will immediately test this one. That so here the difference is at least 3, right? And then I can keep on doing else if it is greater than. Right? So I can do that. So now let's test, and then this else block is not compulsory. So what's going to happen is that is this predicate true? Yes, it is true. Then it will do that, and then after it is done, it is again not going to check this predicate. See, it says that else if. What it means that only evaluate this only if this one is false over here. So after this, the program control will directly jump at the end over here. Okay, so if this predicate is true, do this thing. Else, so what does else mean? It implicitly means that this predicate has to be false, right? Since this predicate was true, it won't execute this. If you want to test both of these things, then actually you can do this, that whether this is true, then you do this. If this is true, then you do this. So if you write else, means that all of these actions, so action over here, action over here, action over here, are mutually exclusive. So only one of this is going to get executed. I'll compile, and now so b was supposed to be greater than a, right? Okay, so I'll write 23 and 24. So this is fine, right? Because difference is not at least 2. Now I'll write this difference is at least 2. In fact, you will see that funny thing will happen. Okay, what happened? Okay, so difference is at least 2 and a is equal to 23. Now okay, we were expecting that it will print that difference is at least 3. What happened? Now let's see that why that happened. See this predicate. So again, right, I think of this as a predicate. So b being 26 and a being 23, for that state, is this predicate true? Yes, the predicate is true. Right? Difference is at least 2. If the difference is at least 3, certainly the difference is at least 2. It is first going to check that whether this predicate is correct or not. It will flow from the program control will flow from top to bottom. So the first predicate that was encountered was this. It just take this action, and here you have written else if, right? So that means that don't execute this if this is correct. Similarly, if this was correct, then it will do this, and then it will say that okay, don't do this. If the program control comes over here, what do you know? You definitely know that then this is false and this is false. Both of these are false. Okay. Now, if I don't have this, then you will see that it is going to print both of them. The difference is at least 2 and at least 3. Right? Now, the difference of at least 4, will it be printed? Just think for a moment. It won't be printed, right? Obvious, because it printed this, and then again this was saying that else. So here else if is connected to this one, that you will do this only if this is false and this is true, right? So when you write else if, it means implicitly that this guy is false and this guy is true. To actually prove that that is indeed the case, now what I am going to write is, so you remember, so this we want to restore the original one, but instead of writing an else over here, right, what I will do is the following. So I'll write another condition. I'll write that it is not the case. So this exclamation mark is a not operator. That means that whatever your predicate is, you flip it, right? So if px was true for certain thing and px was false for something, then there is another qx, make a qx where qx is true if px is false, and like that. It's very easy, right? So it's a negated predicate. So now if it is not the case that b is greater than a plus 1, okay, and so how do you write? So this and this, like both of these conditions have to be true. So for that, this 2 ampersand is the operator. So this is called a logical and that means that I will also add another set of parentheses. Now you see that now if I do 23, 26, again this will not be printed, but this is in the else if. So yeah, I mean, so now the things will change a little bit. See, it did not print. Why? Because implicitly, if I do, whether I do else if, that is another way of saying that the first condition is false and the condition that I am specifying in the else if is true. Just pause this thing for a moment and think about what will happen if it is 23 and 27. Okay. So what's your case? Right? Think about it, and then I'm going to run. Okay, so it didn't print the difference of at least 3, but it print difference of at least 4. Now why did that happen? See, so what happened is that, I hope that this control was examined. So let me just try again. Was A greater than B? A was not greater than B. So between these two braces is completely going to omit that part. That since I know that this predicate is false, I am going to omit it. The control will come over here. What am I writing? Else. It implicitly means what? That you now do the following only if this part was false. Was it false? Yes. So now I'll come over here. B is greater than A. Is it greater than A? Yes. So it's going to print it, which it did. Now B is greater than A plus 1. We gave 23 and 27. So is that the case? Yes. So this predicate holds true for this state where A is equal to 23 and B is equal to 27. So it did print. Now there is no else over here. You see that there is no else over here. What it means is, again you test this predicate and perform an action accordingly. So it tests, okay, so is it the case that B is greater than A plus 1? Yes, that part is true. Means that the negation of that is false. Also, one thing to note is that if the first condition is false, and this is logical AND. Now I don't know whether this logical AND was studied in the school or not, but in a propositional logic, or even in predicate logic, if either of the two argument is false, then the result of the entire expression is false. So either this is false or this is false. But in programming, it tries to do a little bit clever way. So it says that I will evaluate the first one. If the answer to first one is false, I know that, and this is a logical AND, I know that if the first argument is false, then the second argument, I don't have to do anything. The second argument is not going to be evaluated at all. So it does not even run this thing, it will completely ignore. Right? So if the first operand of logical AND is false, it won't evaluate the second part because it knows the end result of the expression. This is called a short circuit. So it does this short circuit evaluation. Okay, so is this false? Yes, this is false. What does it mean? It means that you should not evaluate it. Now you see that again this is a else if. That means that if this is false and this is true, then you evaluate it. Was this false? Yes, this was indeed false. So that's why this becomes true and the difference of at least 4 got printed. Okay, now let me quickly sort of demonstrate the short circuit part. Instead of this, maybe I'll write, so for assert I will do, that's b is equal to 53. In fact, yeah, this is sufficient. So assert in some value. So if the value is 0, then essentially you can put, just like you can put some predicate, assert and some predicate. If that predicate is true, then the program will continue normally, but if that predicate is false, then program will exit. So that is supposed to happen. Let's see. Okay, now I can compile, and then I can give anything. It's not going to matter really, because the assertion failed, because the condition was 0, means false. So since the condition was false, it failed. If it had been true, there wouldn't have been any problem, right? So I'll write 1 over here. Okay, so why is it the case that b is still printed as 27, right? It is because of the short circuit. So let's come back over here, right? So is a greater than b is false? False. Else, what does it mean? It means that this is false, only then you do this. Yes, it is false. Is this true? Yes, it is true, so this got printed. Is this true? Yes, this is also true, that difference is at least 2, so this got printed. Now this is a simple if, so it's going to try to evaluate this predicate, and what will happen is that b is greater than a plus 1. Is it false? This is not false, so this becomes false. It won't even execute this. So b is equal to 53. Now first of all, this is a very dangerous thing. You should not use an assignment inside a predicate. So you remember that this is not mathematical equality. We are not testing for b being equal to 53. What we are saying is that assign 53 to b. So this should not be done, but just for an example. So for example, if I do this, then I'm going into a lot of complexities over here. So this is called an OR operator, that either this is true or this is true. Now when you do b is equal to 53, it will do the assignment, and then it will check that basically what is the value of this. So value of this is 53, which is non-zero, so this is going to be true. Okay. And now you see that the difference of 4 will not be printed because the one before that. So now this wasn't printed. Okay, so I did 23, 24. It should be, let's say, 23 and 26. Yeah, so now you see over here b is equal to 53. So now it got changed. So if it is the logical OR and the first one is false, then it has to still evaluate the second one, because either this or that. But if it is the logical AND, then the first argument, if it is false, it won't even execute the second argument. Similarly, in the logical OR, if the first argument is true, then the second argument does not get evaluated, because you know that the final expression is going to be true. So in the C programming, it does short circuit. My plan was to actually do the switch statement and how this control goes around. But since there was a bug, we tried to do all of this. But at least you learned how to use a debugger. Okay, so I will stop over here. This lecture sort of did not go as planned. But yeah, that is how you learn to debug programs. So I'll stop here. So thank you very much.